Good evening, YouTube. Welcome back to the channel. Back with another video tonight, this time on a new topic that I think I'm finally ready to tackle some labs with. And that topic is NAT, Network Address Translation. So this is the process by which we translate private IP addresses inside of our network into public IP addresses that can traverse the internet and reach other private networks. Everything needs to have an address, but there are a limited number of publicly available IP addresses. And so in an effort to save those, we use private IP addresses, and we can do this translation so that we don't utilize as many publicly available ones as we might if it was always like a one-to-one mapping, or if we were just using public addresses, etc. So NAT is about saving public IP space and translating from a public IP to either a single or a number of different internal private IPs. Today, we are going to use a different source of labs because I made it to a review day with some challenge labs on or in the Cisco CCNA in 60 Days book. We are on day 31, which is exciting. Inside of these, like every 3 or 4 days, you have a review day where you go back and read through all the previous chapters. And since I've already done videos on DHCP and NTP, I'm going to do the remaining challenge labs for this review section, which are all the NAT labs. So there are static NAT, NAT pool, PAT, and then there's an ACL lab, which I don't think we'll do because we're going to be using ACLs when configuring this network address translation. All right, so I think that's it. Let's get into it. So the first things first, we're on challenge 3. If you're following along in the book, this is page 531, day 31 review. We're going to start on challenge 3, and I like these because you have to design your own little networks here, which is kind of exciting. So these 2 routers are the only devices we're going to have for challenge number 3, static NAT lab. Router A and B are going to share a serial link, and then router A is going to have a loopback address created on it. So let's first of all configure the serial connection between router A and router B here. I don't want to do that actually. I need to power it off. Let me zoom in and scroll over, and you can see here we're going to power it off. We're going to take our NIM2T and then power it back on. And that NIM2T is going to house some serial ports for us. All right, powered back on. The same thing with router 1. We are going to zoom in, scroll over, power off, add our new component, I guess is the word for that, and power back on. And then now we can go to our connections and find the serial DCE connection and connect the serial ports. And then these 2 are going to share a subnet, a /30 subnet, that's correct. So we'll jump on the CLI, and the first thing we'll do is make sure that the clock rate is set, question mark, unrecognized command. Where am I at? Oh yeah. Interface serial 010 clock rate. 64,000 is what I've been using. 64,000. All right, and that's only on the DCE side. If we jump over into the other side, which I think might be called the DTE, I could be wrong about that. It'll give us a little error. I'll just demonstrate that. EN conf T interface serial 010, clock rate 64000. This command only applies to DCE interfaces. So only on one side do we need to set it, and then the other side matches it. And that's important for serial connections specifically. All right, so we need to add our little subnet that connects these. It's 192.168.1.0. So we are already in interface serial 010. So we'll do IP address 192.168.1.1, and that's going to be 255.255.255.252 for a /30. All right, and we will do no shut to turn it on, and exit. All right, and now let's jump over to this side. We're already in the interface, so we do IP add 192.168.1.2 /30. No shut. Great, and exit out of that. And I think now we should be able to ping across them because the protocol interfaces are up. So we'll say do ping pong 192.168.1.1, and we are successfully able to send our 5 packets back and forth. All right, now router A also has a loopback interface, so we'll say interface loopback 0, and then we'll do IP add, and it's got an address of 172.168.1.1, 255.255.255.0, I guess /24. I'm not sure that matters. And we don't have to say no shut for these, so that's done. And sorry about that. My phone camera fell over. I'm not going to edit that out because that's a pain. But anyway, sorry about that. All right, next up. We need to, okay, so I didn't even read the instructions. So the instructions can connect 2 routers together with a serial or crossover cable. Okay. Add IP addresses to the routers and loop back on router A according to the diagram. So this whole time I've been looking at the diagram, so that's what we just did. All right, so designate NAT inside and outside interfaces. All right, so the router that we're going to designate inside and outside interfaces on, it's going to be router A. And let me just do host name router A so that it's clear. Host name router B. And then I'll even update this thing. Router A, router B. So add NAT, designate inside and outside interfaces. Okay, so first of all, let's go to interface serial 010. That's going to be the outside interface. So how to explain? We're going to translate, I wish that would stay open. We're going to translate a private address from our loopback interface into a public IP that will then be able to be sent or utilized with traffic going between router A and router B. That's the plan. So the inside NAT interface is going to be our loopback interface, and our outside is going to be our serial interface for router A. So I'm going to jump into the serial interface, IP NAT outside. To designate it as the outside interface, I'll use this command, IP NAT outside. All right, and then I will jump into loopback 0 and say IP NAT inside. All right, that's done. So designate inside and outside interfaces. Add a static route on router B to send all traffic back to router A. All right, so let's add a static route to a default router to capture everything. IP route, and we say 0, 0, 0, 0 to capture everything and a fully open mask. And then we'll just direct everything out of 0, 1, 0 out of that interface, since that's the only one. Default route without gateway, if not a point-to-point interface, which it is, may impact performance. So that's done. Add a static route on router B to send all traffic back to router A. Ping between router A and B to check serial line. Remember clock rates. We did that at the beginning. We already pinged. Let's just do it again. Ping 192.168.1.1. Do ping. All right, and I'm curious if we can ping the loopback from here. Maybe, maybe not. 172.16.1.1. And we can, so we can reach them both. Ping between router A and router B to test the serial line. Remember clock rates, we did that. Create a static NAT for 172.16.1.1 to address 10.1.1.1 and turn on NAT debug. So from here, we say IP NAT inside source static. We're creating a static address. The inside local address is 172.16.1.1. The inside global address, 10.1.1.1. I believe that's it. And then we'll say do IP NAT debug. Maybe that's not right. Let me see. Exit IP NAT debug IP NAT. IP NAT debugging is on. All right, sweet. So now when the debugging is on, whenever this translation is occurring, we're going to see messages about it in the console here. So we have created a static NAT for 172.168.1.1 to 10.1.1.1 and turned on NAT debug. Do an extended ping sourced from loopback 0. So we're going to ping from loopback 0, if I can get that to come up again. We're going to ping from loopback 0, 172.16.1.1 to router B. It will go through serial port 010 on router A here. The translation will occur and it will translate 172.161.1 to 10.1.1.1, which is what we configured. And then that source address on the packet will be sent to router B. All right, so let's try that. We're going to say ping. We're just going to say ping. To what target? 192.168.1.2. Repeat count 5. Datagram size 100. Timeout in 2 seconds. Extended commands yes. Source address. So we can designate a source address. So 172.168.1.1 from the loopback address, not the serial 010 interface address. Enter, type of service, blah, blah, blah. All of these can be by default. And let's take a look. So we can see our debugging issued some logs to the console here. And what is happening? Well, it looks like our network address translation is happening, and as we configured it, a source address of 172.161.1 was translated to 10.1.1.1 to a destination of our other router. And then a packet with a source of our other router's serial interface came in with a destination address of 10.1.1.1, and that address was translated back to 172.16.1.1. So going out gets translated to whatever we designated, whatever we statically assigned. Coming back gets translated back to our private IP address. All right, and then you can see after some time they expire, and your list, if you were using a pool, for example, would become refreshed or replenished for additional use. And that's in fact what we're going to do next. So we did the last thing we did was send the extended ping. Now that extended ping is pretty cool because you can configure your ping instead of just saying ping and then some IP address. So that's a useful tool. Show IP NAT translations, and it's empty now. Let me see if I do the ping again. 192.168.1.2. Extended commands yes. 172.16.1.1. Let the translation occur, and then show the translations. And now we can see them. So we got a bunch of translations that have occurred from inside local to inside global, out to outside local and global. For the translations that we are going to be doing, all of our configuration will be around inside local and inside global, basically our public or our private address translated to our public address, and then that public address is used as the source when communicating with these external outside addresses. All right, so that's the first lab. That's the static NAT lab, challenge 3. Let's do challenge 4 real quick. So I will just restart. I think that's probably the best, easiest thing to do. I'm going to say file new. Do you want to save your changes? No, I don't. All right, so let's do this again. Router A, router B. Configure our serial interfaces. Oops. Turn off, drag, turn on. All right, and for router A this time, connect two routers together with the serial blah, blah, blah. Add IP addresses to the routers and loop back on router A according to the diagram. So in this case, same setup basically. Router A will connect to router B with a /30 subnet. Router A, however, will have 2 loopback addresses. And we're going to be using a NAT pool configuration, meaning we're going to designate a range of IP addresses that can be used for address translation. All right, so let's jump into our serial interface configuration. No, EN, no, 5, 6, yeah. If you're on a Mac, Control-Shift-X will stop the DNS lookup if you accidentally type a thing and a mistake and press enter. EN conf T. So we're going to do serial, not service, interface, serial 010. And we're going to give it the IP address 192.168.1.1, 255.255.255.252 for a /30, and we'll say no shut. All right, and now for router B, no, not NI. EN conf T interface serial 010, IP address 192.168.1.2, 255.255.255.252, no shut, and exit. All right, so that is now done. So we've got 2 interfaces. Let's see, let's connect them. So we go to our connection here. Going to connect 010 to 010. And just to confirm, the interface is already up, but I want to say clock rate 64000, just in case. All right, so we've done that. Now loop router A, and actually let me just ping router B, exit, ping 192.168.1.2, and that works. So packets going back and forth between our two routers successfully. Router A now gets a loopback address, so we're going to say conf t interface loopback 0, and we just need to add the IP address 172.16.1.1, 255.255.255.252. I don't think it matters. And then exit. And then we'll do interface loopback 1. And we'll say IP add 172.16. No, 172.20.1.1. And again, if you're following along, this is challenge lab number 4, the NAT pool lab on day 31. 255.255.255.252. And exit. All right, now, so for next things, what's next? Okay, IPNet. Okay, so it says add IP addresses to routers and loopback on router A according to the diagram. We've done that. Designate inside and outside interfaces. So we're on router A. Let me just configure the host name, router A. And we are going to configure inside and outside interfaces for NAT. So the outside interface is going to be the serial interface. So we'll say interface serial 010. And we're going to say IP NAT outside. And then that's good. And then we'll go to the loopback interfaces, loopback 0, IP NAT inside to make that an inside interface. And then interface loopback 1, IP NAT inside. Exit. So I think that's done. Designate NAT inside and outside interfaces. Okay. Add a static route to router B to send all traffic back to router A. So we've done this before. Let's do IP route. Let's see. IP route O.O.O.O.O.O.O. And we'll send everything out of the serial 010 interface. And we'll get our little error, but this is a point-to-point interface. Okay, so ping router A and B to test, which we've done, but we will go ahead and do again. First of all, host name, router B, and we'll say do ping 192.168.1.1. All right, and also just to confirm, we want to be able to make sure that we can ping our loopback addresses. So loopback 1 will do, .20.1.1. And that works. So we can ping the loopback addresses and we can ping the other router, public interface, serial line. Step 5, create a NAT pool of 10.1.1.1 through 10.10, inclusive. Okay. So let's do that. A NAT pool will be on router A since that's where the NAT translation will occur. IP NAT, let's go back, exit. IP NAT, actually no, is that wrong? Conf T, IP NAT, question mark, yes, define a pool. Pool name, all right, let's do showtop underscore pool. Question mark. Start IP address. So 10.1.1.1 through 10.1.1.10. Question mark. Specify the network mask. I think 255.255.255.0. Seems like that correct thing to do. Although we only want 10 addresses here, it could probably be smaller. Yeah, what limits it? So 255 would be 1, 252 would be 3. 0 is everything. Let's try like 192. Just the first 2 bits. And see what that does. That should give us 10 addresses, I would think. I should probably know that, but I can't think of it off the top of my head. How many addresses does a /26 subnet mask give you? I don't know how to calculate that off the top of my head, which is bad. All right, so create a NAT pool. So we've done that. We've got a NAT pool. Create 2 access lists to permit the loopback networks /16. All right, so create 2 access lists. So access list, standard, permit these /16. So for router A, our two loopback addresses or networks were 172.16, 172.20. All right, so we need to allow those. 172.16.0.0, and that's going to be 255.255.0.0 for a... Actually, no, does this need to be a wildcard mask? It might. I think this needs to be 0.0.255.255. All right, I was correct. And then we need to do access list 2 access list lines. I see. Access list 1. So this is going to be both. Okay, so access list 1, we're going to permit anything from 172.20. All right, from the loopback networks. Great. Let's say do, and the next step is turn on NAT debugging. So do debug IP NAT. NAT debugging is on. Let's see, source. Well, no, I can't do that yet. Check the NAT translation table. It's missing a step because we just created, let's see, we pinged to test the serial line across them. We created a NAT pool. Okay, we created 2 access lists to permit the loopback networks. Yes. Turned on NAT debugging, and then it says now try to ping, but that is not the last step. We need to say IP NAT inside source list show top pool. My kid is up there trying to convince his mom that he doesn't need to go to bed. All right, so show top pool is the pool that we're using. Name pool of global addresses, no. Interface. Let's see. IP NAT inside source. What are our things here? List. Specify access list describing, oh, an access list. List 1. Okay. Pool. Show top pool. We don't want to do overload because that's for PAT. Port address translation, I think is what it stands for. All right, so that is done. Pool start, pool end. Okay. So that's done. And we got actually some logs related to the configuration of that, of turning on NAT. Okay, so now source 2 extended pings, one from LO and loopback 0 and loopback 1. So let's do exit ping, and now to our external address, 192.168.1.2. Yes, extended. Source is going to be 172.16.1.1. All right, and I'm just going to try to do the next one real quick. Ping 192.168.1.2. Yes. Oh, shoot. I got to do it again. Ping 168.1.2. Yes. 172.20.1.1. Try to get it before it. I wanted to try to get it to translate before it expired, like the first one expired, so that we could see the following. Okay, so let's do show IP NAT translations to make sure that's in there too. All right, so we can see it in the logs, but we can also see it right here. So there was a pool of addresses from 10.1.1.1 up through 10.1.1.10. And you can see we sent the first ping and it utilized the first of those available addresses in the pool. We sent a second ping before they expired, you know, the translations or the usage of those addresses expired, like the connection between the private and the public, or I should say inside and global, maybe is a better way to say that, local and global. Anyway, we used the first one, and then for the second ping, we used the second one, and it would go up until it was exhausted. And if the pool was exhausted, we dropped the packet, actually. So that's something that's important to keep in mind. The packet is dropped if the pool is exhausted. Okay, now check the translation table. We already did that, and that's it. So that's the usage of a pool to translate network addresses. All right, so that was challenge lab number 4. And finally, last one, challenge lab number 5. One thing I notice on here is, like, we are still using some ports, it looks like. I think that's what those would be. And we're going to get into that now. So let's do file new. I'll just start it over again. Do you want to save your changes? No. And the same thing. Let's set up our little network again. Very similar. And I'll just do that real quick here. Router A, router B. I think it's good regardless to get practice with these fundamentals over and over and over again, so that when the test comes, it's just like second nature. And turn it back on. Router B. Off. On. Okay, now connect the two. So very similar setup. In fact, I think it's the exact same setup. Let's do configuration of the serial port, enconf-t, interface serial 010, IP add 192.168.1.1, 255, 255, 255, 252, no shut, exit. No, yes, en, conf t, IP add, no. Interface serial 010, IP add 192.168.1.2, 255, 255, 255, 252, no shut. Exit. All right, and then we will open up these connections. connect them over serial 010, adjust the clock rate, interface serial 010, clock rate 64000. That's done. Similarly to last time, this router A, let's do host name router A, and we're going to say interface loopback 0, IP add 172.16.1.1, 255.255.255.255. I think that's, I don't see why that's problematic. Exit, interface loopback 1, IP add 172.20.1.1, exit. All right, so add IP addresses to both routers and the loopback on router A according to the diagram, which we have just done. And just so you can see what these look like, you know, it's basically what you see on the screen. They just give you a little diagram and some configuration guidelines. So for router A, which we are on, designate inside and outside interfaces. All right, so again, like the previous challenge labs, interface serial 010, the one that points outward to the other router. If I can type, that's going to be IP NAT outside. And then interface loopback 0 is going to be an IP NAT inside interface. And interface loopback 1 is going to be IP NAT inside. All right, that's good. Add a static route on router B to send all traffic back to router A. Same thing. Actually, you know what? Why aren't these pinging? I just noticed that. Do ping 192.168.1.2. Let's see. Oh, shoot. So I configured serial 011 on this thing and serial 010 on this one. So that's incorrect. So let's go in here, interface serial 010. I think that was a typo. IP address 010, 192.168.1.1, 255.255.255.252. It overlaps. So let's do this. Exit. Let's go to interface serial 011 and we say no IP address. Can I just say that? And then does it let me? Yeah, it's not set. So I think that worked. However, do I need to go back in 010? Interface serial 010. Let's say no shut. There we go. Nice little debugging. This is why I like doing these labs on video, because you run into like little problems that you have to solve like that. Although I would say NAT, I've been studying it pretty thoroughly. It seems pretty straightforward. I say that now and I watch you like get to the CCNP or something and it's like totally crazy. Let's just confirm that we can ping router B. So that's going to be 192.168.1.2, which we can. All right, so that's good. All right, and yeah, add a static route on router B to send all traffic. Okay, so we need to do that. IP route O.O. .O.O.O.O.O.O. serial 010. That's done. Now, create a static route on router B to send all traffic back to router A. We did that. Ping between router A and B to test the serial line. Remember clock rates. We did that. Create a NAT pool of 10.1.1 address only. Create a NAT pool of 10.1.1 address only and overload this pool address. All right. So let's do that. IP NAT pool, show top pool. Ten 1.1.1, 10 1.1.1, net mask O.O.255.255. Question mark. All right, so we created a NAT pool with one address. I think that's right. And now we will create access lists to allow the loopback networks. I think the net mask is wrong. Let's see. I'm going to say no, IP NAT pool, blah, blah. I'm going to do it again. If you're on Mac, you can press Control A to jump back to the beginning of the line and Control E to jump to the end. This net mask is not supposed to be wildcarded. I think it's like this. All right. Okay, so now we've got a NAT pool. And then let's do access list. What type? Standard. Where we permit what? A /16 network. So we're going to permit 172.16.0.0, and that's going to be wildcarded. So that's going to be O.O.255.255, basically the opposite of the net mask. Enter. Access list 1 permit 2.0. 20, I should say, 172.20. Enter. Okay, now we've done that. And now we just need to enable it, IP NAT, inside, source, list, 1, pool, show top pool. Now is the key difference between the previous video or the previous lab and this one. We actually designate it to overload. So what this will do is, like, since there's only one address in the pool that we use, 10.1.1.1, it will map to available ports and like tie them together. So the network, the internal address, the private address on the side of router A gets translated to 10.1.1.1, and then the message goes across and finds like an open port and then ties that port number to 10.1.1.1 as a unique connection. And that way, when another request comes over using 10.1.1.1, it can tie to a separate port number, and therefore the usage of 10.1.1.1 is overloaded because they're all becoming the 10.1.1.1 address, but they're unique because they're each connection is tied to a specific open port at the destination. All right, so that's what overload does. I'm going to go ahead and enable that, and then we'll say do debug IP NAT. IP NAT debugging is on. Now let's do a ping from loopback 0 to router B. So again, we need to do our extended ping, do ping protocol IP. All right, so the target is 192.168.1.2. All right, yes, extended 172.16.1.1, and get some translations, and let's do another one real quick. do ping 192.168.1.2 dot extended commands yes, source 172.20.1.1, and let that go as well. And then we'll say do show IP NAT translations to make sure we have that data before they become expired. Okay, so we see it in the logs. We had a packet with a source address of 172.168.1.1 that got translated to 10.1.1.1 and then went to a destination of router B, came back, got translated. Then another one, 10.1.1.1. So 10.1.1.1 was used throughout, and on the next ping, again, 10.1.1.1 used as well, which is different from the previous lab where they were both, using sequential available addresses. And we can see here how that overloaded command or overload command says, hey, map to a port, and use that to make yourself unique. Same address, but make yourself unique using one of the, I don't know how many thousand open or available ports that might be there. And actually, that's a good question. I don't know if it's probably using a port on the router A side when the request is going out versus on the router B side. I don't think it can map to an available port, although I'm not sure about that. That might be something to research. All right, we checked, so we sourced the 2 extended pings, and we checked the NAT translations table, which is what we see here. So that was network address translation, NAT. I hope everybody enjoyed that and learned something. Pretty straightforward, at least at this level. Pretty simple concept. I think at the CCNA level, you're only responsible for configuring inside translation and not outside. So that means you're not ever going to deal with translations on this side of the connection. And really just making sure that you remember all the commands, which interfaces are inside or local and global. There's a bunch of terms like inside, outside, local, global. You kind of got to get figured out. But once you do that and you kind of have a good little algorithm sequence of actions to do, it gets to be pretty easy, I think. This book is good for that. These challenge labs, it just steps you through, doesn't give you the answer, just tells you what to do, and implicitly it teaches you that algorithm for configuration, basically. All right, that is it for the night. That was network address translation. If you have any questions, please feel free to post in the comments. We're up to 20 subscribers, which is very exciting. And I would answer any question that came up in there. It's not like I'm bogged down, at least at this point. That's all. Everybody have a good night and have a good work week. See you tomorrow.